Multivariable Calculus 15.5, Day 2. We're finishing up this lesson with example 2. Find the radius of gyration about the x-axis. That would be this thing right here. You're more or less being asked to find y double bar here, and that's, being squared. You can recall from example 1, we found by symmetry that this was pi rho a to the 4th all over 4. And, we did that right up here. But then we also, at the top of the notes here, found out what m was. Now, we did that kind of in a non-conventional way, how we've been finding m in this chapter here. But we could definitely make use of that. We're going to talk about, another thing that we could do. It was, rho times pi a squared. We're going to plug those in, and we'll talk about finding m in just a moment here too, in another way, because many kids probably are going to go back to what we did in the previous lesson, which is fine. I hope you can see immediately that your rows are going to cancel out. You can divide them out. Your pi's are going to divide out. You can divide out a squared from both sides, and what are you left with? Well, it's only going to take you a moment to see. You've got your y double bar squared is equal to a squared all over 4, and that means our y double bar, our radius of gyration about the x-axis, would simply be a all over 2. Now, this m right here, just want to make a side note. I think so very often, if we weren't guided to do that the way we had at the top of the notes, a lot of times kids go to that definition that they saw yesterday, and they could say, hey, wouldn't it be more or less the situation that we did in day 1? And the answer to that is most definitely yes. You most definitely could work this out and say your radius is going to span between 0 and a, and you're going to go between 0 and 2 pi, because we had that circular lamina. And I'll just say, etc. What you'd eventually find is that your m would be what we found at the top of the notes on this page. But notice what you can do as a time saver when rho is a constant. When rho is a constant, you can take advantage of what we did at the top of page 2. So we just found the radius of gyration about the x-axis. We could do the same thing to find the radius of gyration about the y-axis. But hopefully this is making sense. Just, some new definitions and a lot of similar work to what we were doing on day 1.